Hello everyone, this is Mr. McMillan and I'm here with an example problem video for right triangles, the Pythagorean theorem, and trigonometry. So the purpose of this video is to provide you guys with some additional examples that may help you when you're completing, a quiz or the IXLs, whatever else, to give you some strategies in order to be able to do that. Okay. Now, this is being recorded after we've learned about everything that we're going to be learning about right triangles. So this is a few days before the test on right triangles. So please make sure that you take advantage of this video and watch it through. These example problems have also been uploaded to Google Classroom so that you could try them before you watch this video and then check yourself on those. So let's look at number one. It says, which of the following sets of side lengths can represent the measures of the sides of a right triangle? Check all that apply. So this one is your standard check all that apply. And it wants to know what represents a right triangle. Now, if you remember, if a triangle is a right triangle, it satisfies the equation a squared plus b squared equals c squared. And as you remember, that is the Pythagorean theorem. Now, I will tell you that on the SOL test, you do get that Pythagorean theorem, but like anything else, you need to make sure you know how to use it. That way, you are good to go. A formula does you no good if you're not sure how to use it. So let's talk about how to use this one. A and B are our legs. And I typically do the A is the short leg and B is the longer leg. And then C is your hypotenuse or your longest side. Okay, so C is always your longest side. Now, we don't know if these are right triangles, but we do know we would be able to figure out what our longest side is. So let's look here. So we have 8, 15, and 17. And so C is going to be our longest side, so that's going to be 17. A will be our shortest side, which is 8, and B will be 15. So now all we do is we have a squared plus b squared equals c squared, and we want to see if that's true. So we're going to take a squared, which is 8 squared. We're going to add b squared, which is 15 squared, and we're going to see if it's equal to 17 squared. Well, if we type this into Desmos, you'll get 8 squared is 64, 15 squared is 225, and 17 squared is 289. And if we add 64 and 225 together, we get 289. And 289 is equal to 289, so this is a right triangle. Okay, and just to show you on Desmos that would be what you get, we have 8 squared plus 15 squared, which is 289, and then 17 squared, which is also 289, which makes this a right triangle. All right, so let's look at the next one. Here, we've got 6, 8, and 13. So we're going to identify our A, B, and C. C is our longest side, which is 13. A is the shortest side, which is 6. And B is 8. So we're going to take our a squared plus b squared equals c squared. And so that's going to be 6 squared plus 8 squared. And we're going to see if that's equal to 13 squared. 6 squared is 36. 8 squared is 64. And 13 squared is 169. If you take 36 and add 64, you get 100. 100 is not equal to 169, so this is not a right triangle, so we wouldn't mark that one as one of our answers. Okay. All right, the next ones. 6, 8, and 10. C would be 10. A would be 6 and B would be 8. So in this case, we have 6 squared plus 8 squared, and we're going to see if that's equal to 10 squared. So 6 squared plus 8 squared would be 36 plus 64. And if we add 36 plus 64, is that equal to 100? Yes, we already found out that 36 plus 64 is 100. 100 equals 100, so this one checks out as well. All right, 3, 5, and 7. Our C value would be 7, B would be 5, and A would be 3. I do apologize for the freezing of the document camera. So A squared would be 3 squared, B squared is 5 squared, and we're going to see if that's equal to 7 squared. So 3 squared is 9, 5 squared is 25, and 7 squared is 49. If we add 9 and 25, we get 34, which is not equal to 49. So 3, 5, 7 does not form a right triangle. Next up, 12, 16, and 19. Our C value is 19, our A value is 12, and our B value is 16. So we have 12 squared plus 16 squared, and we're going to see if that's equal to 19 squared. So 12 squared is 144, 16 squared is 256, and 19 squared 19 squared is, let's see here, 361. So this is 361. If we add 144 and 256, we get 400, and 400 is not equal to 361, so that would also not be one of the sides of a right triangle. And then 7, 24, and 25, our C value is 25, our A value is 7, and our B value is 24. So we take 7 squared plus 24 squared and see if it's equal to 25 squared. 7 squared is 49. 24 squared is 576. And 25 squared is 625. If we take 49 and add 576, we do get 625, excuse me. So the last one is also a right triangle. Okay. For reference, this would be similar to things that Q.2 was asking you in the IXLs. All right, number 2, it says for the triangle below, what are the lengths of QR and MR? So what I'm going to do is I'm going to put an X and a Y on these two. Now, since we've done this, we've already done trigonometry. By all means, go ahead and use trigonometry. I'm going to use the rules for special right triangles, but trig is what people tend to use after they learn it. It's a lot easier for them. If you do use trig, what you need to do is when you get your decimal for your side length, if it comes up to be a decimal, you need to take your each one of these and see which decimal matches up to figure out which one should be the answer. So let's look here. So if we're trying to do this by the special right triangles like we do in Q4, we see that we have a 60-degree angle here. We only have one side, so we can't use the Pythagorean theorem. We have to use either trig or special right triangles. So we have a 60-degree angle here, and that means that we have a 30, 60, 90 triangle. And the thing about a 30, 60, 90 triangle is it has specific properties. Now, the side that it gives us in this case is the short leg. And we know it's the short leg because it's opposite the 30-degree angle. So we have the short leg. So since we already have the short leg, we can already find the other two things that we need. Now, our formulas are this. The hypotenuse is equal to 2 times the short leg, and the long leg is equal to the short leg times √3. Okay? So let's look at our hypotenuse first. Remember, your hypotenuse is opposite of the right angle. So in this case, y is your hypotenuse because it lies on the side opposite the right angle. So we say that y is equal to 2 times the short leg, and our short leg is 5. So that means y equals 2 times 5, which means y equals 10. And y is on MR, so MR is 10. Next up, we're going to try to find our x value, and x is on the long leg. So we use our second formula there. X is equal to the short leg times √3. Our short leg is 5 times √3, and that just drops down into the answer box of 5√3. Okay. Now you can use trig there. You will get the exact same answers if you use trig. Okay. You just need to make sure that if you do use trig, you label your sides appropriately with the O, H's, and A's. Okay. And then use the correct trig ratio. And we'll talk about those in a bit when those examples come up. All right, number 3. It says, for the triangle below, what is the length of line segment XZ? Now, the key thing here is that we're looking at a triangle, a whole triangle that's been split into 2 congruent right triangles. We know this is a right angle, so this also has to be a right angle. And both of them have side length of 25 and a shared side length of 24. So in this case, we have 2 side lengths. We have 2 side lengths. Anytime you're given 2 side lengths, you can immediately use the Pythagorean theorem. Okay? You can immediately use it. So with that in mind, what exactly is our Pythagorean theorem going to find? Well, we want to find XZ, which is the entire thing. But we have 2 identical right triangles. And if I cover up one of those, well, we'll cover up this one because it's easier. If I cover up one of those, if I use the Pythagorean theorem, I'm only going to find 1/2 of what XZ is. So I need to find this part and then double it to find what XZ is because we're dealing with 2 identical right triangles. So let's do that. So to use our Pythagorean theorem, we need to figure out what A, B, and C are. Remember, C is your longest side. It's your hypotenuse. And so the hypotenuse is opposite of the right angle. So our hypotenuse is 25. So C equals 25. So we found what C is. Now we need to identify what the 24 would be because that's our other side. And you could label that as either A or B. I'm going to label it with a B and label the unknown part there as A. Doesn't matter. It just matters that you label them with the correct things, either A or B. So our Pythagorean theorem is A squared plus B squared equals C squared. And now we plug in our A, B, and C. We don't know what A is, so that just stays A squared. B is 24, so we got 24 squared, and that's equal to C squared, which is 25 squared. Now we simplify what we have, so we have A squared. 24 squared is 576, and that's equal to 25 squared, which is 625. All right. Now from here, the A squared needs to be by itself. It's the only thing with a variable in it, but it still has this 576 there. So we need to subtract 576 from both sides, and we get that A squared is equal to 49. Now, this is what trips up a lot of people. We're not done yet. This a squared still needs to be simplified and something gotten rid of. We just want a, not a squared. So what we need to do is do the opposite of squaring a number. And the opposite of squaring a number is to square root it. So we're going to square root a squared. But what we do to one side, we have to do to the other. So we're going to square root 49 as well. The square root of a squared, the squareds cancel, and that just leaves us with a. And the square root of 49 is 7. So a equals 7. Are we finished? Well, we just said that a is that one part here. It's just this part. Okay, so we know this is 7 now. Okay, now these two right triangles were identical, so we also know that part is 7. And we want to know what xz is. Well, xz is this entire length, so that means xz is equal to 7 plus 7, which is 14. So xz is equal to 14. Be careful about that because that is one of the major things that people get tripped up on. All right, number 4. An equilateral triangle is folded in half. What is x, the height of the equilateral triangle? Now, again, there are a few ways you can do this. This one's a little bit trickier just because of the fact that we don't have everything that we need right now immediately. But it does say that this equilateral triangle is folded in half. So if we fold that in half, we end up with this triangle here. And this entire side was 34 centimeters. So if we fold that in half, this is half of 34 whenever we fold it. So half of 34, that makes this side 17 centimeters. Now, if you'll notice from number 2, we had the exact kind of situation here. We had a 60-degree angle, so we know we have a special right triangle here. Now, with the special right triangle, in this case, we know we have the short side, which is 17. And if we have 17 here, then we can figure out what the long side is. And if you remember, long side equals short times root 3. X is the long leg. The short leg is 17. And then times root 3. So our answer here would be D. The other way you could do this, since you knew this was an equilateral triangle that was folded in half, and this side was 34, this side would also be 34 because it's an equilateral triangle. All the sides are the same. So now you have two sides of the triangle and then x, so you could just use the Pythagorean theorem. So if you did that, you would say that A is your 17, B is equal to x, and C would be 34. So to set that up, you would do a squared plus b squared equals c squared, which would mean that you're doing 17 squared plus x squared is equal to 34 squared, and then solving. You'll get a decimal at the end of that, but when you plug the things in, you'll see that D is the only one that matches up exactly. All right, number 5. Classify the following sets of side lengths as acute, right, or obtuse. Write your answer in the blank provided. So this is building on what number 1 was doing. Now, number 1, we just wanted to determine if it was a right triangle, okay? And to determine if it was a right triangle, we said that a squared plus b squared had to be equal to c squared. But this time it wants us to determine if it's acute or obtuse as well. So to determine if it's acute, when you do a squared plus b squared and compare it to c squared, C squared should be the smaller of the two. Okay, so I'd always just say C squared is small. That makes it acute. Likewise, we say that an obtuse triangle has a large angle in it. So A squared plus B squared and C squared has to be the bigger of the two. So let's look and see what we have in this case. So on A, we have 9, 40, and 41. Just like we did in number 1, we're going to label our sides with A, B, and C. C is our longest side, so C is 41. A is our shortest side, which is 9, and B is 40. Now we're going to do A squared plus B squared, and we're going to do C squared separately. A squared plus B squared gives us 9 squared plus 40 squared. And just to save us a bit of time with all the calculations and everything else, if you plug that in, you would end up with 81 plus 1600, so you would get 1681. Now let's do C squared. C squared is 41 squared, and if you type in 41 squared, you get 1681. Now we're going to compare C squared and A squared plus B squared, and we see that those are equal. So this would be a right triangle. Next up, B, 15, 9, and 7. Our C value is our longest side. So 15 is C, A is 7, and B is 9. Again, we're going to do A squared plus B squared and C squared. So A squared plus B squared and C squared. A squared plus B squared is 7 squared plus 9 squared. So that would give you 49 plus 81, which would be equal to 130. Then you do C squared, which is 15 squared. And if you type that in the calculator, it will give you 225. So now we compare these two to each other, and we see that C squared is much larger than A squared plus B squared. So since 225 is larger than 130, that means it's obtuse. And then finally C, we have 12, 14, and 15. 15 will be our C value, A will be 12, and B will be 14. So if we do A squared plus B squared and C squared, A squared plus B squared becomes 12 squared plus 14 squared. 12 squared is 144. 14 squared is 196. And if you add those together, you get 340. Now let's do C squared. We have 15 squared. 15 squared is 225. And if we compare 225 to 340, we see that our C squared is small. So that means that this would have to be acute. And that is what Q.3 was on. And number 6, for the triangle below, what are the lengths of AB and AC? So again, we're only given one angle and one side. So feel free to use trig on this. If you want to use trig, by all means, go for it. I'm going to use the special right triangle properties because we'll be using trig later in the video. So here we see that we have a 45-degree angle. So since we have a 45-degree angle in the triangle, we are dealing with a 45, 45, 90 triangle. And if you remember, the 45, 45, 90 triangle has its own special properties. First off, the legs are congruent. The legs are the same. The second thing is that the hypotenuse is equal to the leg times root 2. So let's see what it gives us in this problem. So does it give us the leg or does it give us the hypotenuse? Well, the side that's labeled is BC, and if you notice, BC touches that right angle. So this is a leg. And since we're dealing with the 45, 45, 90 triangle, since we already know one leg, we know what the other one is. They have to be the same, so we know that the other leg is 12, and our other leg would be AB. So AB has to be equal to 12. Then how are we going to figure out what AC is? Well, AC is our hypotenuse, and we're going to use the second formula. So AC is equal to the leg times root 2. Our leg is 12 times root 2. So AC is just 12 root 2. Now, once you found one of the sides, either using trig or whatever else, you could always use the Pythagorean theorem. You could use trig to find both sides if you wanted to, or you could use the properties. So this is what I tell you guys when I say that I really don't care which method you use, they're all valid, okay? So just use whatever works for you. And at the end of the day, if you get the right answer using the method, then you know you picked the right thing. All right, number 7. Number 7 says write the definitions of each trig ratio using the appropriate sides, which will be opposite, adjacent, and hypotenuse in the space below. Please make sure that you remember these definitions. Now, I say that, and on the SOL test, on the formula sheet, you will be given the 3 trig ratios. Again, that does not help you if you don't know what the meanings are for those things, okay? So opposite, adjacent, and hypotenuse, you guys probably know what hypotenuse means, but if you weren't sure what opposite and adjacent meant, you might not be able to understand which trig ratio to use. And so you need to make sure you understand that, okay? So sine theta, cosine theta, and tangent of theta. If you remember, we talked about a little memory device, and we said it was SOHCAHTOA. SOHCAHTOA. And the first letter stands for the trig ratio. The second letter stands for what's on top. And the third letter stands for what's on the bottom. And these are isolated. So S stands for sine, and sine is defined as O over H. So that would be opposite over hypotenuse. And you could just say O over H, because when we start working with trig, I'll show you that that's what I do. Okay. Cosine of theta. C stands for cosine, and it says A and then over H. So adjacent over hypotenuse is cosine. And then finally, tangent of theta. Tangent T O over A. So opposite over adjacent. Okay. So those 3 trig ratios are very important, especially if you plan on using trig for any of these problems. Because when we go and label these things, we need to make sure that we understand what we're doing with these. All right, let's look at number 8. Number 8, it says the diagonals of a square measure 18 centimeters. Which is the length of a side of the square? And it gives us a hint here. What angle would be made by the diagonal with each corner? So the first thing is it says the diagonals measure 18 centimeters. So I'm going to go ahead and slap an 18 centimeter on that diagonal. And it wants us to know which is the length of a side of the square. Now, since this shape is a square, we know that the side lengths are all the same. So I know I have right angles because that's another thing with a square, right? It has 4 right angles. And all of the sides are the same. Okay. Now, what type of triangle do we know of that has legs that are the same length? Well, if you answered to 45, 45, 90, you would be correct, right? Remember, 45, 45, 90 triangles have legs that are the same length. So we know this has to be 45 degrees and this has to be 45 degrees. The diagonal cuts that angle in half in a square, okay? So what you could do, if you wanted to, was use the properties of 45, 45, 90 triangles. Well, we don't know the legs, but we do know the hypotenuse. So we're going to do it 2 ways. We're going to do it with the 45, 45, 90 properties as well as trig, okay? This is why I say most people prefer trig, because trig is you do the same thing every time, whereas the special right triangles are special cases. So our hypotenuse in a 45, 45, 90 is equal to the leg times root 2. Our hypotenuse is 18. Our leg is x, and then times root 2. Now, root 2 is just a number, so we're just going to go ahead and divide both sides by root 2, and we get that x is equal to 18 over root 2. And if we type that into Desmos, 18 over the square root of 2, we get 12.73 as our decimal, okay? So what you need to do in those cases, if you choose to use that method, you need to plug in each one of these to see which one matches up. And I'll spare you some trouble here. B is going to be the one that matches up. If you type in 9 square root of 2, you get the exact same decimal. So in this case, our answer would be B. Okay. Now, let's verify that using trig. Okay. So our theta is going to be equal to 45. Remember, our theta is going to be an angle that that's not the right angle. We know what our hypotenuse is, so we know what h is. Now, since the legs on a square are the exact same, or the sides of a square are the exact same, we can use either the opposite side or the adjacent side. Okay, so I'm going to use the opposite side. So I'm looking for O and I know H. So I need to use the trig ratio that deals with O and H. That would be sine. So we put sine of theta. Well, theta was 45 degrees. And that's equal to the opposite side, which is x, over the hypotenuse, which is 18. Then we're going to put sine of 45 over 1, and we're going to cross multiply. So x times 1 is x, 18 times sine of 45. Then you just go into your calculator in Desmos and plug in 18 times sine of 45. So we do 18 sine of 45. And as you can see there, it gives us the exact same thing, 12.73. So for the most part, here's what I'm going to recommend. Use trig, okay? It's easier to remember than the 45, 45, 90 properties. And this method works with any triangle where you're given one side and an angle, and you want to find one of the other sides, okay? All right, number 9. Number 9 says triangle PQR is a right triangle. What is the length of QR? So it wants us to know What is that? What is QR? Now, the key thing here in these types of problems is to look and see what you have. How many angles do you have? How many sides do you have? And if you look here, we can see that we don't have any angles other than the right angle. We only are given two sides. The key thing here is when you have two sides, when given two sides, use the Pythagorean theorem. Okay? When you're given two sides, use the Pythagorean theorem. So that means we need to figure out what our A, B, and C are. Okay? So remember, C is always your hypotenuse, and your hypotenuse is opposite the right angle. So that means that 22 is our C value. Then for the rest of it, we can label either one of these as A or B. Okay? I'm going to label the unknown as A and 18 as B. I normally do A as the short leg, but if it's unknown, you know, it doesn't really matter. Your Pythagorean theorem is A squared plus B squared equals C squared. We don't know what A squared is, so we just drop it down. We know B is 18, so we have 18 squared, and that's equal to C squared, which is 22 squared. A squared drops down again. 18 squared, I believe, gives us 324. Yep, 324. And 22 squared gives us 484, I believe. Yep, 484. So 484. All right. Now we need to get the A squared by itself. So we subtract 324 from both sides, and you end up with A squared equals 160. Now, we're not done yet. And the reason we're not done yet is because we still have this pesky square hanging around. Well, in order to get rid of that, what we need to do is take the square root. So we're going to take the square root of both sides. The square and the square root cancel. That gives us A equals, and if we type that into the calculator, 160 and then the square root, we get that A is 12.65. So that means QR is approximately 12.65. Now you may get a situation where it's exact, like it's in an exact radical form, like it was up here. Just make sure that you plug each option into your calculator correctly to see which decimal matches up. Okay. All right, number 10. Number 10, it says determine the value of sine of A, cosine of A, and tangent of A in the following right triangle in simplest form. So all it wants us to do is figure out what sine, cosine, and tangent would be. Okay, so sine of A, cosine of A, and tangent of A. All right. The key thing here is normally theta goes here. So it says that we want sine of A. Well, sine of A, we would put our theta where A is. So theta is your angle. Just remember that. Now we have a triangle with three sides here. So what we need to do to figure out sine, cosine, and tangent is to do find out what our opposite, adjacent, and hypotenuse are. Okay. The one I like to go for first is the hypotenuse because it's always consistent. So the hypotenuse is opposite of the right angle. So in this case, that means that 35 is your hypotenuse, which is H. All right. Next up, we're going to do the opposite side from tangent. So opposite means opposite from tangent. So the side that does not touch where theta is the opposite side. And so would that be 21 or would it be 28? Well, 21 touches theta, 28 doesn't, so that means 28 is our opposite side, and that would mean 21 has to be our adjacent side. So next up, we have our three sides labeled, so now we can do our sine, cosine, and tangent. Sine is defined as O over H. So in this case, O is 28, H is 35, and it says in simplest form, so we need to see if those fractions will simplify. So I'm going to show you this first one here. In Desmos, you're going to type in 28 over 35, and it gives you the decimal 0.8. We're going to see if that can be simplified. There's this circle with a fraction bar here. You're going to click that, and it's going to simplify it to 4 over 5. If it gives you the same thing, it just meant it was in simplest form before that. So this is equal to 4 over 5. Next up is cosine. Cosine is adjacent over hypotenuse. We labeled our adjacent side as 21. Our hypotenuse is 35. And if you type that in the Desmos and simplify, you'll find that that is 3 over 5. And then finally, tangent of A. We have tangent is opposite over adjacent. Our opposite side is 28. And our adjacent side is 21. So 28 is O, or 28 over 21. If you plug that into Desmos, it will simplify to 4 over 3. All right. Next up, number 11. Number 11, it says a right triangle is shown below. What is the value of x rounded to the nearest tenth? So again, you're going to ask yourself, well, what do we have in this problem? Well, it gives you one side and it gives you one angle, and it wants you to find another side. So when it gives you one side and one angle, you need to use trig. Okay, so we're going to use trig here. So our theta is going to go on the angle that is not the right angle. So theta is going to be 33 degrees. Then we label our sides O, H, and A. Our hypotenuse is always opposite from the right angle. So that makes 13 our H. So what would X be labeled as? Would it be labeled as O or A? Well, X touches is on the side that touches theta. So that means X would be A and our empty side would be O. Now with the trig ratios, you need to make sure you use the correct sides and the correct ratio based on it. So let's look here. We have A that we want to find, and we know H. So we need to use the trig function that uses A and H. Well, the trig function that uses A and H is cosine. So we have cosine of theta. Well, theta is 33, so we got cosine of 33, and that's equal to adjacent over hypotenuse. So the adjacent side is X. The hypotenuse is 13. We have a fraction on the right side. We're going to make the left side a fraction as well by putting it over 1. And then we're going to cross multiply. So X times 1 is X. 13 times cosine of 33. If we type that into Desmos, you end up getting X equal to 10.9 because it wanted us to round it to the nearest tenth. So X is equal to 10.9. Number 12, in the figure below, what is the length of the hypotenuse to the nearest tenth? So it wants us to find the hypotenuse. Again, what you're wanting to do is figure out if you're given two sides already or if you're given just one side and an angle. And the key thing here is you're given an angle and one side. So it wants us to find our hypotenuse, and our hypotenuse would be here. Our theta is the angle that's not the right angle, so it would be 49. And 19, would that be your opposite or adjacent side? Well, 19 is on the side that does not touch theta, so that means it would be opposite, and the blank side would be adjacent. So I'm going to put an X on the hypotenuse there, just to make it a little bit easier. Our opposite side is 19, and our hypotenuse is what we want to find. So we need to use the trig ratio that deals with O and H. That's sine. So sine of theta, which is 49, is equal to the opposite side, which is 19, over the hypotenuse, which is X. Put sine of 49 over 1 and then cross multiply. 19 times 1 is 19. X times sine of 49. Now, sine of 49 is just one number. If you type sine of 49 in the calculator, it'll give you a decimal. And we need the X by itself. So what we need to do is get rid of that sine of 49 by dividing it. So that means that X is equal to 19 over sine of 49. So X is going to be equal to sine of 49. And we round that to the nearest tenth. So that would be X is equal to 25.2. And that is our hypotenuse. Okay. All right. So what differed with that was that the sine of 49 ended up on the same side as the X. So you needed to divide to get rid of it. Anytime that your unknown value is on the bottom of this fraction, the last step will end up being dividing the number that was on top by the trig function. All right, number 13, it says a 15-inch long diagonal in a rectangle makes an angle of 29 degrees with a length of the rectangle as shown below. What is the length of the rectangle to the nearest tenth? So it wants us to find the length. So we're going to put an X on the length. And it gives us one angle and one side. So that means we need to use trig. So our theta is 29 degrees. 15 is opposite the right angle. So that is our hypotenuse. X is on the side that touches the theta. So X is A, and our width is the opposite. We're not worried about the width because we don't need to know what it is. Okay, so we have A and H here. So A and H, the trig function that deals with that is cosine. So we have cosine of theta, which is cosine of 29. And that's equal to A, which is X, over H, which is 15. Put cosine of 29 over 1, then cross multiply. X times 1 is X. 15 times cosine of 29. If we plug that into Desmos, we get that X is equal to 13.1. So our length of this rectangle would be equal to 13.1 inches. Number 14, what is the value of C in the triangle below? Round your answer to the nearest hundredth. So this time it wants 2 decimal places. So it wants us to know what is the value of C. So we're going to be looking for this. So it gives us one side and one angle. So theta is going to be 64. C is on the side that does not touch theta. So it's going to be our opposite side. And 12 is on the side that does touch theta, so that's our adjacent side. And B is our hypotenuse. Since it does not ask for B, we're not going to worry about it. We only want to know C. So we know what A is. We want to know what C is. So that's O and A. So the trig function that deals with that is tangent. So we have tangent of 64 is equal to the opposite, which is C, over the adjacent, which is 12. Put tangent of 64 over 1, cross multiply, and we get C times 1 is C. 12 times tangent of 64. Going to plug that into Desmos. We get that 12 times tangent of 64 is 24.60. So C is equal to 24.60. All right, last two. Given the diagram below, what is the measure of angle R? Now, if you have a right triangle and it asks for the measure of angle R, guess what? You're going to be using trig. Specifically, you're going to be using those inverse trig ratios we talked about. So it says, what is the measure of angle R? So we're going to put theta on R, and we're going to label our sides with O, H, and A. So our hypotenuse is opposite the right angle, which is our 23.7. Our 19 is on the side that touches theta, so that's going to be our adjacent side, and our empty side is going to be O. Make sure you know what the question is asking you for, because what I see a lot of times is that they'll see that there's two sides and then go, ooh, Pythagorean theorem, but it's not asking for that other side, it's asking for the angle. Okay. So we have A and H as our two sides. So the trig ratio that deals with that is cosine. So cosine, this time we don't know what theta is, and that's equal to our adjacent side 19 over the hypotenuse 23.7. Now, since we're trying to find theta, we need to get rid of this cosine. In order to do that, we need to do the inverse cosine. So theta is going to be the inverse cosine of 19 over 23.7. And if we plug that in, we'll go to our keypad here, functions, inverse cosine, 19 over 23.7. And we get that theta would be equal to 36.7. So the measure of angle R is 36.7 degrees. All right, then our last one here, number 16, a right triangle is shown below. What is the value of X rounded to the nearest tenth? And you have to look and see where X is. Is X a side or is it an angle? If it's a side, you can use the Pythagorean theorem, most likely, or trig, depending on how it's set up. If X is an angle, you know you're using trig. In this case, X is an angle, so that's going to be our theta. We're going to label our opposite, adjacent, and hypotenuse. 34 is opposite the right angle, so it's our hypotenuse. 22 is on the side that does not touch theta, so that's our opposite, and then our blank side is at the adjacent. We have our opposite side and our hypotenuse. The trig function that deals with that is sine, so sine of X is equal to opposite 22 over hypotenuse 34. We're looking for X. We already have those sides. We're not going to put it over 1 and cross multiply. So we're going to take the inverse sine of both sides. So we end up with X is equal to the inverse sine of 22 over 34. And if we type that into our calculator, we get that X would be equal to 40.3 degrees. Okay. All right. So that does it for this video, guys. I know it was a rather long one, but I wanted to work through a bunch of examples. And if you're having, issues with this, I do appreciate you watching this. And looking through these and seeing how they're worked out. Okay. If you do have further issues with some things, make sure that you join the Zoom sessions, email me for help. I'll be more than happy to help. But unless you let me know what you're having some issues with, I can't help you out. Okay. So make sure you do that. Wednesday there will be a concept check posted for attendance purposes. It'll be a few questions on this type of stuff. It'll have feedback for when you complete it. And then Thursday we'll do a test review. And then Friday we'll take the test on right triangles. Okay. So thanks guys, and I will see you in the next video.